Well, we do too. Okay. Uh, we can close the door on the combined gas law, Boyle's gas law, and Charles's gas law. And sometimes what happens is we close that chapter of your, if you want to call it your book, and we move on to the next one, which is, you could say, maybe the dreaded gas stoichiometry. We're not quite that far yet. This is what we'd still consider as composition gas stoichiometry, because from prior knowledge, we addressed something similar last semester. So, as a quick reference, how we make note of that, remember last semester, okay, it might have said something like this. So, how many moles of, we'll say, sodium chloride are found in, we'll just use that same number, 18 grams, okay? That is composition stoichiometry, where you're just dealing with one compound only, or one element and one element only. Then, as the semester had progressed, then you move on to reaction stoichiometry, which is what we had wrapped up in the month of January, which might have said something similar to this. If you have 18 grams of chlorine, how many grams of sodium chloride can be formed, okay? So all the way up to here, that was composition stoichiometry. Then this next question was reaction stoichiometry, okay? There's a clear difference. Do we understand that? Because now we're doing composition gas stoichiometry, which means the expansion of 18 grams of nitrogen would lead to how many milliliters of nitrogen? We're just dealing with one substance in one substance only. Because eventually what will happen is you're going to have a chemical reaction that accompanies this as well. So there are some similarities that what we have learned from prior knowledge, but in this case, two things you're going to have to combine: dimensional analysis and the Eagle. Eagle.
IGL.
Yes. Eagle is ideal gas law, which is this one. Okay? So one of the aspects, oh, I left this off here, not intentionally. A lot of the questions that you'll see on that first paper, STP is your friend. Okay? It makes things a lot easier. Because on worksheet 2, sometimes you're not calculating a pressure of a gas, a volume of a gas, the temperature of a gas. Sometimes it's not at STP. So there are some presumptions that can be made when we're dealing with a gas at STP. Okay? And does anyone remember? What is the pressure of a gas at STP? 1 atmosphere. Okay? So pressure is 1 atmosphere. Okay? Now, we're looking for volume, so we can't use that as a presumption. That will come later. Okay? So, what is the temperature of a gas at STP?
273 Kelvin.
Okay? So then what happens is this R is actually a constant. Okay? We've dealt with constants before. Okay? If we want to know the distance around this circle, you're going to have to know what that distance is. Take this x times 2. Oops, boy, I'm butchering this. And times 3.14. Okay? So 2 pi r. That's right. So x is your radius. You double that, you take it times pi. So it's a different way of writing it. Okay, so 3.14 is a constant. Okay, we drop something, and it will accelerate at a constant rate. 9.8 meters per second squared. That is a constant. Okay, so for every mole of a substance, a constant will tell you how many atoms of that substance are present. And it's Avogadro's number is also a constant, 6.022 times 10 to the 23rd. Okay, so in order to solve this, okay, notice we're missing some parts of our puzzle up here, if you want to call it that. Okay, this is a constant, which is 0.0821 is a constant. That is your R value. Okay? So with what we have here, we know the pressure of the gas. We know the temperature of the gas. And you're agreeing? Yes, we know that? Must be. Okay. So I don't know how that pertains to this other than really get hopping here. Okay. So we know the temperature. We know what R is. How can you solve an equation with two unknowns? You cannot. Unless you do that in algebra, that 2x plus 3y equals 9. It is. It's, I agree, it's not fun. But in this case, okay, yeah, I'm sure that's what that phone call is. So, but can we know this value, we're looking for this. So N is a number of moles. That's all that N means.
N equals moles?
N equals moles. That's right. It's in the binder. I used that as a bookmark, didn't I?
That's a great bookmark.
Okay? Okay? So, what have we learned so far? Just like in physical science, you've read the problem, you know your equation, what should you do next? Some of you are very good at this. Other people are just, I don't know. Is it laziness? Is it we don't care? I don't know. Yes?
Write down what you know.
Okay? And some of you are smart enough that you might not have to do that. That's fine. But if you do that, be prepared to face the consequences should you choose not to do that. It's a choice. Okay, so what is the pressure? We said that. It's 1 atmosphere. Okay? What is the R value?
0.081.
Okay? So we know what T is because how can we just start filling in this content when there's no other numbers in this problem? Because it's at STP. You know that. How do you know it's at STP? We just told you that here, even though it's in a different color marker. Okay? Now, that means we're looking for this, the volume, in milliliters. Okay? So how can we get that N value? Because remember, N is a number of moles. Is this a known substance? Yes, it is. So how can we take any bit of information that we see here, okay, and this is going to be human nature, okay, except this, okay? So from all the way back to last August, okay, we want to take this 18 grams. Don't write this part down. This is what I'm saying is going to be human nature. This, I guarantee you, it's going to happen. And chances are, from what you've seen so far, what number might people put down there? Why are you right? Okay? Human nature. People are going to tend to forget to do that, to do this. Now, once you've looked at that, you're going to say, oh, I need to put 28 down here. But when you show your work like that and you label it, you will not make that mistake. At least that's the goal. Now that you solved your moles of nitrogen, we can place that in there. So that means 18 divided by 14. Oop, I almost did it myself. 18 divided by 28.02. That gives us 0.036. So 0.036. That's moles of N2. Okay? So now that you've done this, we've got every variable except for our volume. Okay? So you can take a shortcut for this. What is any number times 1?
Itself.
Okay? So notice on the left side of your equation, you really don't have to do a whole lot of complex math for that. Probably the most complex portion of that is remembering to do this to make sure it's diatomic and put that in for your N value. Oh no.
Yeah.
0.642.
0. Oh, what part? Sorry.
The division.
The amount
of moles.
18 divided by 28.02 is 0.642.
I'm not doubting. I just.
Probably just hit an extra button, or the decimal didn't go.
I like your thinking. I'm going to use that as an excuse.
I'm serious about the decimal. Because like if you do it divided by 2,802, it's probably that.
Good catch. Okay? So, yes, 0.64. It wasn't intentional, 0.64 moles of N2. Okay? So, in short, what you're going to do is multiply these three numbers. Okay? But here's the trick. Okay? You have a 50-50 chance, but I'm willing to bet that you're going to get this right. The moment that you multiply these three numbers, okay, that value of a volume is going to be in liters or milliliters. It's going to be in liters, okay? Because this R constant, when we get later on down the road, especially in gas stoichiometry, the volume of a gas can be considered as 22.4 liters. But that's in reaction stoichiometry. That is not in composition. Those couldn't be any further apart. You've got to wrap your head around that. This was hopefully meant to be informative on how to do. So moving forward, okay, I highly suggest that moving forward, tomorrow and or Thursday and possibly even Friday, what is the best thing that you can do for yourself?
Ask for help.
That too. You got your binoculars, do that from, I'm just kidding. But see, you're listening though. That is true. But now when we're at home, yes, but good point. The Science Channel. Here is your last chance. Who does not know how to get to the Science Channel or find out how to get to these videos? Okay. So, the one that has the question that deals with methane, that is worksheet 1. Worksheet 2 is going to be a little more difficult, okay? But I will provide that information for you on the Science Channel, okay? So it would be to your benefit to tune into that. Does that make sense? Okay, I need to check something here real quick. Please hang on. To the best of my knowledge, I would presume that it's time to move on to your 7th hour class because, as you had stated earlier, I think we're getting out at 2 o'clock today. Okay? So please, do yourself a favor, tune into the Science Channel, and I don't know when that will be. It might not happen till 2 o'clock in the afternoon, okay? Because
I get notifications from one.
okay, so that is the best thing to do for yourself for updated information. We'll catch up to you next time.